Close your eyes for a moment. Not to sleep, but to imagine. Every night, without fail, you surrender to an ancient ritual. You lie down, close your eyes, and for the next several hours, you essentially become unconscious. If you really think about it, sleep is one of the strangest things we do. We spend roughly a third of our lives in this vulnerable state, and yet, we barely understand why. But here's what we do know. While you're sleeping, your brain is anything but quiet. In fact, in some ways, it's more active than when you're awake. Tonight, when you drift off, your brain will embark on a carefully choreographed journey through different stages of consciousness, each one serving a purpose so vital that without it, you would literally lose your mind. Let's start at the beginning. The moment you close your eyes and begin to relax, your brain starts to change. If we could peek inside your skull right now, we'd see waves of electrical activity rippling across your cortex. When you're awake and alert, these waves are fast and chaotic, like a choppy sea. But as you relax, they begin to slow down, becoming more rhythmic and organized. This is the transition into stage 1 sleep, the lightest stage. Your muscles relax, your heart rate slows, and your body temperature drops slightly. This stage lasts only a few minutes, a brief threshold between waking and sleeping. You might experience sudden muscle jerks called hypnic jerks. These are completely normal, though scientists aren't entirely sure why they happen. One theory suggests they're remnants from our evolutionary past, a reflexive check to make sure we're safely positioned before fully letting go of consciousness. Within 10 minutes or so, you slip into stage 2 sleep. This is where you'll spend about half of your entire night. Your brain waves continue to slow down. But now something interesting appears. Suddenly, brief bursts of rapid brain activity called sleep spindles erupt across your cortex. These spindles last only a second or two, but they're incredibly important. They're thought to play a crucial role in memory consolidation, helping to transfer information from short-term to long-term storage. At the same time, something else appears on the brain scan. Large, slow waves, called K. These are the brain's way of keeping you asleep despite external noise or disturbances. Think of them as your brain's do not disturb sign. When a sound occurs in your environment, a K complex might fire to suppress your awakening, allowing you to continue sleeping peacefully. But we're still in the shallow end of sleep. The really profound changes are about to begin. After 20 or 30 minutes in stage 2, your brain waves slow down even further, becoming large, rolling delta waves. Welcome to stage 3, also known as deep sleep or slow wave sleep. This is the stage that makes you feel refreshed and restored when you wake up. Without enough deep sleep, you'll feel groggy and unfocused no matter how many hours you spent in bed. During deep sleep, your brain is producing these massive, synchronized waves of electrical activity. It's as if billions of neurons have decided to fire in perfect harmony, creating these slow, powerful oscillations that sweep across your cortex like ocean swells. It's during this stage that your brain does some of its most important housekeeping. Throughout the day, as you think, learn, and experience the world, your brain cells produce metabolic waste. Proteins and other cellular debris accumulate in the spaces between your neurons. For years, scientists wondered how the brain cleaned up this mess. Because unlike the rest of your body, the brain doesn't have a traditional lymphatic system to flush out toxins. Then, in recent years, researchers discovered something remarkable. During deep sleep, the spaces between your brain cells actually expand by up to 60%. Cerebrospinal fluid rushes through these channels, washing away the accumulated waste products. It's like your brain has a built-in dishwasher that only runs at night. Among the debris that gets cleared out is a protein called beta, which is known to accumulate in the brains of people with Alzheimer's disease. This discovery has led scientists to suspect that chronic sleep deprivation might increase the risk of neurodegenerative diseases. Deep sleep is also when your body does most of its physical repair. Growth hormone is released, tissues are rebuilt, and your immune system gets reinforced. This is why sleep is so crucial when you're sick or injured. Your body literally needs this time to heal. But as profound as deep sleep is, it's not the star of the show. That honor belongs to the stage that comes next. After cycling through the first few stages of sleep, usually about 90 minutes after you first dozed off, something extraordinary happens. Your brain suddenly becomes almost as active as when you're awake. Your eyes begin to move rapidly beneath your closed eyelids, darting back and forth as if watching something. Your heart rate increases. Your breathing becomes irregular, and your brain waves speed up dramatically. You've entered REM sleep, rapid eye movement sleep. And this is where things get truly strange. During REM sleep, your brain becomes a paradox. The parts responsible for logic and reasoning, particularly your prefrontal cortex, become less active. Meanwhile, the parts involved in emotion and memory, like your amygdala and hippocampus, light up like fireworks. The visual processing centers in your brain become incredibly active, even though your eyes are closed and you're not seeing anything. And here's the truly bizarre part. While all this is happening, your body becomes temporarily a cluster of neurons in your brainstem actively suppresses signals to your muscles, effectively disconnecting your brain from your body. Only your diaphragm and eye muscles remain active. This paralysis serves a crucial purpose. It prevents you from acting out your dreams, which could be dangerous. This is the stage where most of your vivid, narrative dreams occur. And dreams, it turns out, are far more than just random neural noise. They appear to serve several important functions. First, REM sleep plays a vital role in emotional regulation. During this stage, your brain processes the emotional experiences of the day, but in a unique neurochemical environment. Noradrenaline, a stress hormone, is completely absent during REM sleep. This allows you to replay emotional memories without the same intensity of feeling, helping you process and integrate difficult experiences. It's like your brain is running exposure therapy on itself, taking the emotional sting out of memories while preserving the important information. Studies have shown that people who are deprived of REM sleep have much more difficulty regulating their emotions. They become more reactive, more anxious, and less able to read social cues. In a very real sense, REM sleep keeps you emotionally balanced. REM sleep is also crucial for creativity and prurience. During this stage, your brain makes unusual connections between seemingly unrelated pieces of information. This is why you sometimes wake up with solutions to problems that stumped you the day before. Your dreaming brain, freed from the constraints of logic and linear thinking, can explore possibilities that your waking mind would never consider. There's a famous story about the chemist August Kiku, who discovered the ring structure of benzene after dreaming of a snake biting its own tail. Whether or not the story is literally true, it captures something real about how REM sleep can facilitate creative breakthroughs. But perhaps the most important function of REM sleep is memory consolidation. During this stage, your brain is actively deciding what to keep and what to forget. It's strengthening important memories, integrating new information with existing knowledge, and pruning away unnecessary details. Interestingly, not all memories are treated equally during REM sleep. Your brain seems to prioritize emotionally significant memories and information that's relevant to future goals. It's as if your sleeping brain is curating your memory library, deciding what's worth preserving for the long term. Throughout the night, you cycle through these stages multiple times. Each cycle lasts about 90 minutes, and with each cycle, the balance shifts. Early in the night, you spend more time in deep sleep. As the night progresses, your REM periods get longer and more intense. By morning, you might be spending up to an hour in REM sleep during a single cycle. This is why the last few hours of sleep are so important, and why cutting your sleep short, even by an hour or two, can have such a significant impact. You're not just losing time in bed, you're losing your most intensive REM sleep periods, the ones that do the heaviest lifting for emotional regulation and memory consolidation. What's fascinating is that different species have evolved different sleep patterns based on their needs. Dolphins sleep with only half their brain at a time, keeping the other half awake to surface for air. Some birds can do the same thing, keeping one eye open and half their brain alert for predators. Prey animals like horses and elephants sleep very little, while predators like lions and house cats can sleep for 16 hours a day. Humans fall somewhere in the middle, but what's unique about us is the proportion of our sleep spent in REM. We spend about 20 to 25% of our sleep time in REM, which is unusually high for mammals of our size. Some scientists believe this is connected to our complex social lives and our need for emotional intelligence. Others think it's related to our capacity for abstract thinking and creativity. Babies spend even more time in REM sleep, as much as 50% of their total sleep time. This makes sense when you consider how much learning and brain development is happening during infancy. Their brains are constantly processing new information, forming new connections, and quite literally building themselves. As we age, our sleep patterns change. Older adults tend to spend less time in deep sleep and REM sleep, and more time in the lighter stages. They also wake up more frequently during the night. This is one reason why older people often report feeling less rested, even if they spend adequate time in bed. But here's something important to understand. These changes don't mean older adults need less sleep. They need just as much as younger adults, roughly 7 to 9 hours. They're just having a harder time getting quality sleep, which can have significant consequences for cognitive function, emotional well-being, and physical health. Modern life has created unprecedented challenges for sleep. Our ancestors went to bed when it got dark and woke up when it got light. Their brains were perfectly synchronized with the natural rhythms of day and night. But now we have electric lights, smartphones, and 24-hour entertainment. We can stay up as late as we want, and our brains are constantly bombarded with blue light that tells them it's still daytime. The consequences of chronic sleep deprivation are more serious than most people realize. It's not just about feeling tired. Lack of sleep affects every system in your body. Your immune system weakens, making you more susceptible to illness. Your metabolism is disrupted, increasing the risk of obesity and diabetes. Your cardiovascular system suffers, raising the risk of heart disease and stroke. Cognitively, sleep deprivation is devastating. Your attention span shrinks, your reaction time slows, and your judgment becomes impaired. Studies have shown that being awake for 18 hours straight impairs your performance as much as being legally drunk. Your memory formation is compromised, both for facts and for skills, and your emotional regulation falls apart, making you more irritable, more anxious, and more prone to depression. Perhaps most troubling is that we're terrible at recognizing our own impairment. When you're sleep deprived, you feel like you're functioning reasonably well, even though objective measures show you're not. It's similar to being drunk in that way. You think you're fine, but you're actually making mistakes and missing things you normally wouldn't. So what can we do to protect our sleep? The science points to several key strategies. First, consistency is crucial. Going to bed and waking up at the same time every day, even on weekends, helps regulate your circadian rhythm. Your brain likes predictability. Second, create a sleep-friendly environment. Your bedroom should be cool, dark, and quiet. Even small amounts of light can disrupt your sleep, so consider blackout curtains or an eye mask. Temperature is also important. Your body needs to cool down slightly to initiate sleep, which is why a room temperature of around 65 to 68 degrees Fahrenheit is ideal. Third, be mindful of what you consume. Caffeine has a half-life of about 6 hours, which means that if you have a cup of coffee at 4 in the afternoon, half of that caffeine is still in your system at 10 at night. Alcohol might make you feel drowsy, but it actually disrupts your sleep architecture, particularly your REM sleep. And large meals close to bedtime can interfere with sleep by keeping your digestive system active. Fourth, manage your light exposure. Get plenty of bright lights during the day, especially in the morning. This helps anchor your circadian rhythm, but in the evening, dim the lights and avoid screens for at least an hour before bed. If you must use devices, enable blue light filters or wear blue blocking glasses. Finally, develop a relaxing bedtime routine. This signals to your brain that it's time to wind down. This might include reading, gentle stretching, meditation, or a warm bath. The key is consistency and relaxation, not stimulation. Understanding what happens in your brain during sleep should change how you think about those 8 hours you spend in bed each night. You're not wasting time. You're not being lazy. You're engaging in a sophisticated biological process that's absolutely essential for your health, your cognition, and your emotional well-being. Every night, your brain embarks on this remarkable journey through different states of consciousness. It cleans itself, consolidates your memories, processes your emotions, and prepares you for the challenges of the next day. It's one of the most complex and important things your body does, and yet it requires nothing from you except the willingness to close your eyes and let it happen. So tonight, when you lay your head on your pillow and feel yourself drifting off, remember what's about to unfold. Your brain is about to perform its nightly symphony, a carefully orchestrated sequence of biological processes refined over millions of years of evolution. Deep sleep will wash your brain clean and repair your body. REM sleep will process your emotions and strengthen your memories. And when you wake up tomorrow morning, you'll be restored, refreshed, and ready to face another day. Sleep isn't a luxury. It's not something you can cheat or cut corners on without consequences. It's a fundamental pillar of human health, as important as the food you eat and the air you breathe. In our always-on culture, choosing to prioritize sleep is an act of wisdom and self. Your brain has been taking care of you every night since the day you were born. Perhaps it's time we start taking care of it by giving it the sleep it needs. Sweet dreams.